We are going through exercise 6C, and in this video I'm going through 3A. So let's give it a read. It says, without dividing, show that the first polynomial is exactly divisible by the second polynomial. So here are our two polynomials. Now the key phrase here is exactly divisible, which means that this is a factor of this. Now let's just begin by defining what these things are. This is my divisor, and this one over here is my dividend, which we represent with p of x. Now, if it's exactly divisible, we know that this is going to be a factor, which means we'll be using our factor theorem, which tells us that p of alpha equals 0, then x minus alpha is a factor of p of x. So it's all a bit wordy here, but as you can see, x minus a, they've set it equal to 0, or x minus alpha rather, x minus alpha, they've set it equal to 0 and found that x equals alpha. They then sub that into their polynomial, their dividend, and they have 0 out, which means that it is a factor. So let's now do the same. We're going to take our dividend here, x minus 1, we're going to set it equal to 0, then solve it. So it's going to be x equals 1, then I'm going to put that into my dividend, my p, and then that is going to be p of 1 is going to be equal to, now I'm going to put that 1 into every time I see an x, so it's going to be 1 cubed minus 1 squared plus 1 minus 1, which is going to wind up being 1 minus 1 plus 1 minus 1. Then you can simply go, well, 1 minus 1 cancel, 1 minus 1 cancel, so I'm obviously going to be left with 0. And that right there proves that x minus 1 is a factor of x cubed minus x squared plus x minus 1. The fact that I got a 0 proves that x minus 1 is a factor. So hopefully this video has been helpful for you in understanding what the factorum theorem is and how to apply it.